Polymers. How plastic is formed? In the beginning, plastic is a liquid, is a watery liquid made of monomer. And this monomer, soon they will form into a block of strong solid. And you may wondering, how does this liquid, watery liquid, will form into a strong block of solid? And this is called polymerization. As follows. This individual monomer will link up together and form into a long chain called polymer as follows. Now they form into a long strand of polymer. How long will this polymer be? Could be from a 5,000 monomer unit to 15,000 monomer unit long. And in between them, there is an attraction force called the dispersion force, which bind them together. So now let's look onto the bigger picture. So if there is many single strand of polymer chain, and now this in between them there is a dispersion force which bind them together, and then what will be resulting? The resultant is this liquid monomer will form into a block of solid because the strand between strands are bind to each other through dispersion force. So, student, please take notice. What is the individual monomer? Double bond ethene. It is a double bond ethene. And what is the polymer? Hydrocarbon chain. And because hydrocarbon chain, between hydrocarbon chain, they have an attraction force, that is the dispersion force, which bind them together. So if you look onto the top of the picture, molecule of plastic is very much like your spaghetti that you eat. But this time it is a molecule spaghetti with a very, very long strand. And between strand and a strand, they attract together through dispersion force, which make it to form into a block of solid. Now let's look onto the molecule structure. Of each monomer, they make of ethene. Each monomer are ethene. What is ethene? 2C of a double bond. So the ethene double bond will open and link with other monomer as follows. You see this double bond, and this double bond will be reactive, and this double bond will break open. And now once they break open, and between one and the other, they will link up together. And now they form into a chain. So now they are no longer double bond. Single unit is a double bond. When they form into a chain, they become a single bond now. And they are both hydrocarbon. And now let's take some example. Imagine if I have 5 pieces of ethene. I have 5 pieces of ethene of monomer. If they polymerize together, what will they form? They will form into one chain of polymer of 5 individual pieces that link up into one chain. Now, what should be the name of the monomer? CH2 double bond CH2. So student, pay attention to the molecular structure and the naming. What you call CH2 because this is CH2. Double bond, CH2, CH2. Student, you require to know the structure well and the name well. And once they open up and link, what will be the polymer molecular structure be? The formula structure will be look like this. Now they still CH2, but now they become a single bond rather than double bond. And what happened to the side of the bond? Now they link to each other. They link up to each other. And so in the beginning, this monomer is 5 individual pieces. Now this become one chain of 5 repeating of CH2. So this is a 5 repeating in a chain. This 5 represents 5 individual monomer. Student, please understand. Now let's talk polymer. There is 2 common types of plastic. One is called the thermoplastic. What is thermoplastic? You will become soft and flexible when you heat, so it can be reshaped and remolded. So they are made of a long chain of weak dispersion force between chain, and so they can easily slide past each other when you heat. And as you see in this boy who tried to blow up this bottle and put it under the stove to heat to reshape it into a ball. What's meant by long chain with weak dispersion force between chain? What does that mean? Let's go detail. Look onto the molecule. Each chain is a hydrocarbon chain. Each chain is a hydrocarbon chain. It's a long spaghetti. Between this long spaghetti, there is a dispersion force, a weak dispersion force that bind them together to make them into a block of solid. So, when you heat it up, means vibration. And this dispersion force will break. And once the dispersion force breaks, and then the chain will slide past each other, and that's called melting, as follows. So now you can see this plastic under heat and it melt. That's what you see very common. And this is to demonstrate each chain of hydrocarbon of this polymer. In between them there are dispersion force, which is breakable by heat or by too much stretching. And that's how a solid is made, a plastic is made of. And now I'm going to introduce another special type of plastic. This special type of plastic on the other side called thermosetting. This is a hard plastic. They cannot be softened by heat. Oh, that's strange. How come they cannot soften by heat? Don't they have dispersion force? And when you heat, they will melt? Now I'm going to talk about something called cross-linking. On this plastic, they also made of a hydrocarbon chain. They also have a dispersion force between. But they have one more factor. In between chain and a chain, they have a covalent cross-link with one and the other, which when you heat, you stop it from sliding past each other, so you cannot melt it. Once you overheat it, it will burn and it will break, but it will not be softened by heating and melt. As follows. So, you can see that they cannot be moved because chain and a chain are bound by this cross-linking covalent bond. The application, for example, your electric switch or the lemonade table, they are made of this type of plastic. So on these two examples, I want to demonstrate one point. Plastic, they are made of monomer. They make of polymer. And this polymer are hydrocarbon. Between hydrocarbon, they have dispersion force that bind them together. And when you heat, it will soften up and melt. But with thermal setting, when you heat, because by this cross-linking, it will not be melt. Now, we just learned what's plastic made of. This polymer made of individual monomer. And we're going to talk more about this individual monomer ethene. Now we're going to study two types of polymer. They both come from the ethene. One is called a high-density polyethylene. The other is called low-density polyethylene. Look at the name. High density. That means these polyethylene are more dense together. Low-density polyethylene. They are less dense. They are not too dense. What do I mean by these two words? Now let's look onto the molecule structure. If you look onto the molecule structure, they are made of spaghetti, as we know. And this type of spaghetti, between them, there is a dispersion force to bind them together. And if you study detail in each individual chain, they are a long chain, and this long chain, they don't have too much branching. And so this polymer can pack quite tight together. They can pack more tight together and more dispersed force between them. So give them the strength and tough. They are quite strong, but you cannot bend it too much. They're quite strong and durable. And we use it for the bucket or children toy, lunchbox, and play equipment. Here's demonstrate the strength of this plastic. If you apply force to push it, it can bend to a small degree as follows. Or if you pull it, it can bend in a small degree. And now, that's why these plastics are quite dense packed. So we call high density polyethylene. And now I'm going to look onto the low density polyethylene. The name implies they are less dense. That means they are not too crowded together. They're quite loose. Why they're so loose? The trick is, if you look onto the individual of this chain, of this polymer, they have many branches. I highlight one for you. You can see of this spaghetti, they are not only a single strand, but rather in each single strand, they have many branching like a tree of the branch. If you have that many branches, you cannot pack it too close together. That's why this branching, when they're numerous, it cannot be packed together tightly, and the dispersion force between strands is reduced. That's why the density is low. And these plastics are soft and more flexible plastic. And you can use it like the glad wrap or some plastic bag or some squeezable plastic bottle. They are a soft type of plastic. Now I'm going to apply force to it to pull it, and you see what happened. When I apply force to pull, it will stretch and stretch and stretch and stretch and stretch. So this type of plastic, they are less packed, but they quite flexible, but they are not very strong. As example, we use our glad web. So now you can see one strong plastic, which is tough, another soft plastic, which is soft and flexible. Of this addition polymerization, we each make of the individual monomer to polymerize into a long hydrocarbon chain. And we study ethene. And now we're going to look onto other, like vinyl chloride or styrene. Each individual monomer, even they look different, but they have certain common. They all have a 2C and they all have a double bond. This double bond will be according to the old rule. They can open up and link to each other. Even they have a different functioning group. What I mean by different functioning group, like ethene, you have a H. Vinyl chloride, you have a Cl. Styrene, you have a ring shape. So this is the different functioning group. So even you have different functioning group, but because of this double bond, you still can open up and link to each other. So you will be subject to the same addition polymerization rule as follows. PVC. Student, please know the name. It have a common name called vinyl chloride. Vinyl chloride. And you also have a system name called chloroethene. Chloroethene. Why it called chloroethene? Because it is a ethene double bond 2C with a chlorine. So it called chloroethene. That's the system name. And now how is it polymerized? Same rule, double bond, open up and link to each other and form into a chain. Example, 5 pieces of individual monomer, they link up together, form into one chain of polymer with 5 repeats. And I just only change the functioning group of the box into chlorine as follows. And so they subject to the same polymerization rule. So student, please understand how's the chemical reaction, how is the double bond open link. Knowing the monomer and the polymer. Don't just try memorizing the shape, but understand how does the reaction take place. PVC, as we mentioned, the common name vinyl chloride, system name chloroethene. PVC is one of a very famous useful plastic. It can have formed into many different uses. For example, you can make it into a rigid form of plastic, like on the outdoor. You can see some pipe, some white pipe, this PVC rigid pipe. But on the other hand, PVC can also make into a flexible form, like the gardening hose. This is to demonstrate PVC can make it into a hard plastic as well as into a soft plastic, and they can add by different color. as for white color or in green or many different color you can apply. So PVC is one of a very common versatile plastic that you should know. Another plastic called polystyrene. The common name is called styrene. The system name is called ethyl benzene. Why this name so funny? Because this time we look onto the benzene as a base. This benzene ring as a base. So whatever sticking up, we treat this group as ethyl. So that's why it's called ethyl benzene. Student, please know the name. The rule will be the same. Double bond, open up, link. And example, if I have 5 individual monomer, they will link up into one chain of 5 repeat polymer. And what is the difference? The functioning group. Instead of early example chlorine, I change it into a ring. I just change it into a ring shape. And this is become a new type of polymer, a different type of plastic. Of this polystyrene, you have a common name called styrene. And you also have a system name as we call ethyl benzene. And what is the common use? This common use is called styrofoam. When this plastic melts, you're blowing gas bubbles through it, and it will form into a bubble foam. And when this foam hardening becomes solid, you will form into you will trap many gas in between. So this gas trapped inside this foam, it make it into an excellent lightweight insulator as to make as a SK, fast food container, and packaging material. Like on the picture you show for packaging, because they lightweight and as a food container and a good insulator. Summary. So far we learned 4 types of plastic. Of these 4 polymer, high density polyethylene, they are a long chain spaghetti, they unbranch. This unbranching and with many hydrocarbon with dispersion force between, make them strong and tough. You can use it for bucket. Low density polyethylene, they are the branching hydrocarbon. This branching hydrocarbon, they are more flexible. You can use it for cling wrap. Styrene, they use for the styrofoam when you blow bubble through this melted plastic. Now they trap many gas bubble and they make it into a lightweight insulator. This lightweight suitable for package material. Insulator suitable for using for thermal cup. PVC, very versatile by adding different stuff to it. Example, coloring. You can make it into hard plastic as well as soft plastic. As example of outdoor pipe, water hose, and outdoor furniture. Student, please understand this polymer. How does this polymer for affecting its molecular structure? And this molecular structure give different type of property and use. Thank you.